Larry Deokinath Maharaj, and you can visit learn.mo.gov.tt, where you can find resources for ECCE, primary and secondary, where students connect and continue learning. So our lesson today would be primary science at standard 3 level. The strand would be form and function, and the topic that we are focusing today would be the laboratory thermometer. So we all have heard about the thermometer. We have encountered it from the time we were born and throughout our lives. Every time we go to a doctor or we are doing experiments, even on your barbecue grill or on your stove, thermometers could be found any and everywhere, giving useful information. So, what is a thermometer? Why do we use it? So, from what we just spoke of, thermometers are used to measure temperature. And that is basically how hot something is or how cold something is. It gives a number to that. So sometimes we would say it's really hot out here, or something is really cold. But being scientific, we need to actually put a number to it to be able to say for sure, hey, this could compare to that, or this is what it really is. So by using a thermometer, we could actually measure how hot or cold something is. So again, in science, we have special units we always use. These units are used throughout the world, and especially important when we are calculating stuff, or even if we are sharing the information, we would be speaking the same language and using the same measurements. So for temperature, we use the degrees Celsius, and the symbol would be the little O on top with a capital C underneath. So that's the symbol for degrees Celsius. So as with all equipment, we have different types. Thermometers are no different. Depending on the use, we would have them differently shaped and designed, but keeping in mind that they all give the same information, how hot or cold something is. So we basically have two main types. The first one would be a clinical thermometer. And as the word says, clinical, like when you go to the clinic, the doctor, for a checkup. And when you go for a checkup, you are testing your body, how hot or cold you are. So the difference in a clinical thermometer would be the values, the markings of how hot or cold that thermometer can read. So look what we have here, 35 degrees Celsius to 42 degrees Celsius. Because of our body temperature, and it doesn't go way much below or way higher, we don't need to have a thermometer to measure all the temperatures above and below. So it's generally, we want to keep it around there. So clinical thermometers have a very short range of values from 35 to 42 degrees Celsius. So that's one. We have the laboratory thermometer, and we use these in science, outdoors, experiments. It's for general use. So most of the thermometers you would find would be a laboratory thermometer, and the range is very, very wide. We go from very cold to very hot, and the range here, as you can see, measures temperatures between minus 10 degrees Celsius, which is 10 degrees colder than 0 degrees Celsius. So that's 10 degrees Celsius colder than ice. Water freezes into ice, that's how cold, up to 10 degrees Celsius. And then on the higher value, on the hot side, it could go until 110 degrees Celsius. So a laboratory temperature thermometer could give that a wide range of temperatures for whatever we need to measure. So, as with all equipment that we use, all devices, we need to be familiar with it, parts of it, and how to use it. So, first thing first, a thermometer has a long stem which is marked to show the temperature. So, it's thin and it's long. So, the markings, it was what we would use to get the actual degrees Celsius. So, we'll see shortly how to do that. At the base, there's a bulb, and as the word says, bulb, just like a light bulb, it's rounded, it's enlarged, and it's at the base. The bulb stores a liquid which increases in volume when heated. So, at the base of this narrow tube, we have that liquid. And the very important thing about it, temperature affects matter. And it affects volume. When things get hot, they tend to expand. And we could see this quite clearly with liquids. So this is why we use liquids in most of these thermometers that we see. The liquid, when it gets hot, it would expand and it would rise along the thermometer, and we already have markings, we just read it off. So let's look at our diagram here. So this is a bulb, as we mentioned, it's rounded and the liquid is stored. So in typical liquid thermometers, we could usually find two types. One where the liquid filled is mercury, or one which is filled with alcohol. Typically, to tell the difference, the mercury thermometers, the liquid would be kind of grayish to silver, and the alcohol would be colored, and it's usually colored red. So it is stored in this bulb, and if we look here, we notice the scale, which is the markings. And inside from the bulb, there's this narrow tube where gives it room for when the liquid inside here increases with temperature, it would travel up the tube, and wherever it stops, we look at that line and read it to get our temperature. If it becomes colder, the volume would decrease and it would go back down. And again, we read the marking on the scale and we get our temperature. It's very simple, yet so important. So we have the material here typically being made out of glass. So it's very fragile and you have to be very careful when handling it. It's also used because glass conducts heat easily. So it'd be able to give you a quick reading, a good reading, and that's what we want when we are taking measurements. So in reading a thermometer, we look at where the meniscus lines up with the mark. And we come across the word meniscus. Again, that's where a liquid is in a container. Get that little curve. So we use the meniscus to line up the mark to give the reading. So we have a diagram here. Again, it's a bulb underneath, and we have the markings. And over here would be where our fluid, the liquid is. And we look at the bottom of the meniscus and line it up. So over here, it lines up with 0. So the temperature, if I was looking at whatever I was measuring with this thermometer, would read 0 degrees Celsius. In using a thermometer, again, we need to make sure we understand this. The bulb stores the liquid which increases when heated. And that's the main thing we need to remember in how a thermometer works and how it functions. The heated liquid would move along the stem, allowing the temperature to be measured. And in the actual use of the thermometer, we have certain rules. And if we are placing a thermometer into a liquid, the bulb, and remember the bulb is where the liquid is at. And this is where the changes need to take place. So when we are using a thermometer, the bulb should be fully immersed into the substance which the temperature is being measured. What that means is that the bulb needs to be completely inside of what it is. So if it's a jug of water, the bulb needs to be completely covered inside that water. So the bulb in this case, since we are using a laboratory thermometer, the bulb must be fully immersed into the substance at which it's measuring. Very important, as we'd be using thermometers in the lab, we'd typically be using the thermometers into beakers or containers similar in shape and size. Very important, and this would go to the point that we just mentioned before, and we have it here in bold. The bulb must not touch the sides of the beaker or the container. And this is very important because the liquid or the substance in the beaker or the container is what we are measuring. If the bulb touches the sides of the container or the base of the container, we would not get a proper temperature reading because it is not in full contact and completely submerged or immersed in the substance itself. So this is one of the major precautions when using a thermometer, that the bulb should not touch the sides of the beaker or container. The stem should be held at the top so the thermometer does not, the temperature of the thermometer does not affect. If the bulb stores the liquid and it's based on how the temperature here affects the volume and it travels up. When we are using a thermometer, we hold the top of it, so we would not get the heat from our bodies heating up the liquid inside of the thermometer. So we would not affect the readings. For our activity, I would need an assistant, and today we have Vritti who would be helping me. So here we have a laboratory thermometer. Hold. Right. And as we could see, we have markings, and if we look at the top of the thermometer, we would see the degrees Celsius, as we mentioned before. That's what we are measuring in. And then we would have all the numbers, the 110, which we spoke about, 110 degrees Celsius, and then going all the way down, this one goes to -20. And the base, we have the bulb filled with the red liquid. And in this case, it is alcohol because we mentioned the color. And the liquid would expand, and look, it would go all the way up. So in this thermometer, we could see it. It's highly visible with a red marking. And we could read the thermometer, and it's 20 9 degrees Celsius where this was. So now we would move on to our activity. So what we would need for the activity: a beaker, a spoon, a metal spoon, butter, a bean, boiling water, tap water. So today we have 3 different beans, so this could be done using whatever you have. It's just to show the effect and how it happens. So we have something which you may or may not use called a retort stand. When I'm measuring temperature, I could simply, as we mentioned before, hold the top and hold the thermometer into whatever I am measuring until I get my reading. In some cases, where you would need the thermometer to be there for longer, you may need something to hold it up. So what I have here, this shiny metal thing here with the arms, is called a retort stand, and that's just to hold things in place. So I could stand and do the same experiment today, holding it like this, but we could use the retort stand instead of just standing there. So let's see what we have. A small pat of butter is placed at the top of the spoon. So we have the spoon, a metal spoon, and the butter. So let's take a little bit more. Scoop it. Put it back. A bean is placed. So today I would like to use lentils. So I have lentils, split peas, red kidney beans, but I think today we'd use the lentil. So we take the lentil and just stick it. So we have our lentil stuck to the pat of butter on top of the metal spoon and tap water. So here we already have the tap water poured, and because it's there with the retort stand measuring the temperature, we would actually get the temperature of the tap water. So we read the bottom of the meniscus, which gives us at eye level 22 degrees Celsius. So what we do now, hold it like this, and we just place it carefully inside. And we observe. Observe, again, we use our senses, being scientists, young scientists, old scientists, or just being curious. We observe. So we are looking now at what would happen with the tap water at room temperature, what happens to the bean on the butter, on the spoon. So if you look at it, we have our beaker with our thermometer, and importantly, as we said, it's completely submerged, not touching the edges. So again, all of the precautions that we measured, we mentioned not spilling and making sure that we have the spoon resting properly. And then observe what happens. So as we took all of our precautions, now we wait and observe what takes place in this experiment. So we observe for 5 minutes what took place, and as we can see, it remains the same. The pat of butter with the bean is on the same spot. No change has occurred. So I would like to thank Vritti. Thank you very much, Vritti, for helping me today. Okay. Right. So now we would like to repeat the experiment using hot water. So here we have the same amount of hot water we used as when we did the experiment with the tap water. And again, same things we apply. The thermometer, this bulb is fully immersed. It's not touching the sides or the base. And we could take a temperature reading. So now again, we go back down. And at eye level, right now the water is at 80 degrees Celsius. So that's very hot as when we compare it to the 22 degrees Celsius of the tap water. So again, we do the same thing. We have the pat of butter with the bean, and now we are following the same procedure. Place it carefully, the spoon, and we observe for 5 minutes what takes place. So again, that's what we did. So again, we have the hot water there in the beaker, same amount, and we would like to ensure at this point safety is always our main concern. So if you are doing this at home, make sure an adult is with you and they are using the hot water. So we have our concerns here with the hot water, not making sure that the spoon doesn't fall into the beaker. And now again, as we did before, we observe for 5 minutes what changes take place, and then we compare it to what we got when we had the spoon with the butter and the bean in the tap water at 22 degrees Celsius. So after 5 minutes, we notice the heat from the hot water in the beaker has melted the butter and the bean. And if we do that, just shake it a little bit, you see that the butter and the bean would move and drop. So we have now information to compare what has happened to the water that was 22 degrees Celsius, the effect it had on the butter with the bean, it remained, and the water at 80 degrees Celsius, it melted the butter and the bean dropped. So now we could compare, and we could only know for sure what happens because we now have numbers to work with. Hope you had fun, and remember, science is fun.